This is Module 1, Video 2 of Math 5840. In this video, we're going to define a number of terms. In particular, we're going to define node adjacency, link adjacency, what it means for a node to be incident to a link, node degree, node in degree and out degree, and isomorphism. Before we go to the material that's in section 1.5, I would like to make a remark about section 1.4. 1.4 will be assigned as a reading assignment, and there's a lot of terminology in section 1.4 that you may not be familiar with. We will be defining some of the terms that are used in section 1.4 later. So for now, just glean what you can from the reading and know that the terms that you're not sure of, not to be concerned about at this point. So now we'll go to section 1.5. In section 1.5, we define the following. We define what it means for two nodes to be adjacent. Two nodes are adjacent if they are joined or connected by a link. A node is incident to a link if the link connects U to another node. So a node U is incident to a link E if the link connects U to some other node V. We say two links are adjacent if they are incident to a common node. So we use the term adjacent when we're talking about either two nodes or two links, and we use the term incident when we're talking about one of each. A node is incident to a link. So we have said, or given the following definition, that two nodes are adjacent if there is a connecting link. So looking at the small network on the right, the nodes C and A are adjacent to each other, and the nodes B and D are not. We frequently refer to a link by the pair of nodes that it connects. So for example, consider the link AC, or we could have said CA. The links AC and BC are adjacent to each other because they have the common node C. The links AB and DC are not adjacent to each other. And the node B is incident to the edge BC. The degree of a node is the number of links that it's incident to. So what is the degree of node A? What is the degree of node B? Do you agree? The degree of A is 3, and the degree of B is 2. Now, if the links have assigned direction, then we have to distinguish whether the link is pointing away from or pointing to a given node. So we say we partition the links into two classes and have in degree and out degree. So for the directed graph below, do you agree that the out degree of the node labeled 1, the node labeled B is 1, and the in degree of the node labeled B is also 1? Let's look at the node labeled A. Do you agree it has out degree 2 and in degree 1? Our last definition is isomorphism. We say two networks are isomorphic if there is a one-to-one correspondence between the nodes that preserves adjacency. In the example above, the corresponding nodes receive the same label. So, for example, if we find the node label 4, in the representation on the left, we see that 4 is adjacent to the nodes 5, 8, and 3. So if we find the node labeled 4 on the right, the network on the right, we see that the node labeled 4 is again adjacent to the nodes labeled 5, 8, and 3. We can check this for each and every node and see that the adjacency relationship has been preserved and that these are actually the same network. So we have discussed the following terms: node adjacency, link adjacency, what it means for a node to be incident to a link, and what node degree is. If the edges have direction, then we have node in degree and out degree. And our last definition was isomorphism. This is the material discussed in your reference book or your textbook on pages 14 through 16.